Okay, in this unit we're going to talk about square roots and Pythagorean theorem, hence the title. Before we start with square roots, we're going to talk about square numbers and area models. So something is a quadrilateral with 4 right angles. So quadrilateral means 4 sides, and 4 right angles, that means they're 90-degree angles. So something with 4 sides and 4 right angles, if we look at it, oh look, it's a rectangle. We have a rectangle as a quadrilateral with 4 right angles. A square also has 4 right angles. So let's draw a rectangle with a base of 1 centimeter and a height of 4 centimeters. I can't really measure this on here very well, but you can do that. But I'll draw what it might look like. So it's got a height of 4 centimeters and a base of 1 centimeter. So this would be 4 centimeters, and this would be 1 centimeter. And now we're going to draw a rectangle with a base of 4 centimeters. So base of 4 centimeters and a height of 1 centimeter. Kind of looks like a Tetris cube. And if we look, really these are exactly the same thing, just rotated. Just like you would if you were playing Tetris. And these two rectangles are congruent. That means that they have the proportions are the same and the angles are the same. They would be equivalent actually too. So right, that they're equivalent as well. No, we'll just leave that out. We'll leave that up. There we go. Is every square a rectangle? Well, does every square have 4 sides and 4 right angles? Yep. So yes, every square is a rectangle. Is every rectangle a square? Well, let's think about what makes a square a square. A square is a square if all 4 sides have exactly the same length, but does every rectangle have all 4 sides exactly the same length? No. So not every rectangle is a square. Apparently we don't want to. There we go. No, not every rectangle is a square. Look at technology. It is annoying. Okay, there we go. Use the grid paper to draw as many rectangles as possible with each of the following areas. If you want to use tiles or blocks to help, you can. These are on the next 2 pages. I am not doing those with you. You can do those. You can pair them with a partner, but I will leave that up to you. Once you're done doing those, drawing those rectangles, here's some questions here. So for how many of the above areas were you able to make a square? So you were able to get the area that was up above, but also make a square with it. Make sure you're listing those there. Check them with a partner. What is the side length of each square you made? Again, write it down, check it with partner. How's the side length of a square related to its area? And find 2 areas greater than 20 square units for which you could use tiles to make a square. So you would need at least 20 tiles, and you want to make a square, and you want to find the area of that. So again, work on these questions with a partner. If you aren't quite sure or aren't agreeing with something on something, you know where to find me. Also, how do you know you can make a square with these areas? Okay, going from here, when we multiply a number by itself, we square the number. By the way, please pause and do that before you go on. You can come back to the video after. For example, the square of 4 is 4 times 4, so 16. So we can write 4 times 4 is the same as 4 squared. So we write a little 2 up there, which is 16. So 16 is a perfect square. Or another word that I can't remember right now, and so you can look that up in the textbook. We are going to show that 49 is a square number. We're going to use diagram, symbols, and words. So using a diagram, 49 is a square number. if I didn't know offhand what two numbers I could multiply to get 49, I could sit there and work it out. We know, let's go not too small to start. We know 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7, oh look, that's 49. So hopefully I can 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, and 6. So now we've got 1, 2, 3, 4, 5, 6, 7 by 7. So this is 7 units by 7 units, and it makes a square, therefore 49 is a square number. Using symbols, so that's our diagram, using symbols, it would just be 7 times 7, which is 7 squared, is 49. And then words, so this is symbols, and then 7 squared is 49. Oops, not 9. 9. Period, because that's the end of a sentence, so we use punctuation. Notice also that I started with a capital. That would be using words. By the way, perfect square or a square number, if you didn't look that up already. Which I'm going to wager you probably didn't. A square picture has an area of 169 centimeters squared. Find the perimeter of the picture. So doing this without a calculator, you have to think a little bit about what some numbers are. So 169, kind of big-ish. So if we looked at, maybe we could start at 10. 10 times 10 would be 100. By the way, I really recommend learning your perfect squares, and so you know them off the top of your head. So 10 times 10 is 100. 11 times 11, 121, 12 times 12, 144. We're getting really close. As it turns out, 13 times 13 is 169. So we have this picture. It's 169 square centimeters. If I were to do little centimeter cubes, I would find out that it was 13 centimeters this way and 13 centimeters this way. So we want to find the perimeter. The perimeter means the distance around. So there's 13 centimeters on top, then 13 centimeters on one side, 13 centimeters on the bottom, 13 centimeters on the other side, because it's a square, as said there. And if we add those all up, it would be 13 times 4, so I guess we just multiply them instead, and that is 52. So the perimeter of the picture is 52, and 52 what? Well, it's distance. How far do you go? You go kilometers or meters, or in this case centimeters, so the perimeter is 52 centimeters. And now you can do your own practice with those questions. The extra practice, these aren't questions you have to do, but I really strongly encourage, especially if you are planning on going into a higher level of math once you get into high school, just to get some extra mathematical thought processes going. And even if you're not, take a look at them and see if it's something that interests you as a challenge.